All right, hello again, everyone. This is Jeff Scott, formerly of Rankin Technical College. And in the last lecture that I did, I started to go through this article, and I had to pause, and it was actually quite a long pause. But during that time, Camtasia went down. It saved what I was working on. So basically on here, what I have done is I've gone through the first 4 rows. So I've got the first 20 terms that I've gone through under every Python keyword explained. Out of those first 20 terms, there are 4 of them, yield, lambda, width, and class, that I have not gone over yet. All right, and I'm going to be going over later as we go on, but I wanted to continue on. And the next one, really the next 2 that are in here, are both talking about looping concepts. All right, so I'm going to jump back into my program, and one thing I'm going to do, I haven't done it yet, but one thing I'm going to do quickly is I'm going to separate this out into a whole big group of programs so that they are in there. So if you want to see them individually, then you'd be able to do so. All right, so again, let's comment out some of this stuff that's in here. Now, back in the day, when I really, when I first started teaching many years ago, when I started teaching computer science, data processing, whatever you want to call it, one of the things that we talked about quite a bit was we talked about the concept of structured programming. And more than anything else, it dealt with 3 things. And those are sequence, selection, and iteration. Now, with sequence, you just do things one after the other. When I first created the first part of this program, and I had these 2 lines here, it went in and basically the program went in and it created 2 random numbers, each between 1 and 100. Then we went down here and basically we call those functions that we'd written. All right, but the idea was we were doing things in a sequential top-down type of manner. Then we went on a little bit and we talked about things like an if statement. And an if statement is an example of selection, where you've got different paths that you can go down depending upon conditions. So sequence just basically means you're doing things one after another. Selection means that you'll go down, you could have different paths and you choose one and you go down that path. Now, the only thing we've talked about so far with selection is we've talked about if with elif, if with elif and else, and if with else. All right? Those are basically the different patterns you can have, and you can have 1 or more elifs in here. All right? And you don't have to have an else. So there's a lot of different permutations or combinations. Now we're getting into iteration, which really is involved with looping. So we're going to talk in just a second about a for loop, and we'll also talk about a while loop. Now let's see, do I have that? Yeah, I still do have that in here. All right, I'm going to try to run this right now. For I in range 5, print I. And let's see what happens, okay? We get 0, 1, 2, 3, and 4. What does that mean? That means that by default, all right, unless told otherwise, I starts at 0. And as long as I is less than 5, print the value of I. All right, now this is one way of writing a for loop, and we'll go over others as we go on. But the point is this. What you'll notice, if we wanted to go up to and include 5, we could do this. And then you'll notice we'll have 0, 1, 2, 3, 4, and 5. But the point is, what we're doing here is we're going through things repetitively. We've got a loop that we're using in here. All right, so that's a for loop. Now that is a very, very simplistic look at a for loop. But the idea with a for loop is it's a counting loop. All right, so you need to know how many times you're going to go through it. On the other hand, we also have in here a while loop. Let's see the example that they gave for a while. All right. Nothing wrong with the example, but I'm going to change it a little bit. All right, because here we printed out the values of 0 through 5. So we'll set here n equal to 0. And we'll say while n is less than or equal to 5, print n, and then add 1 to n. What we should get in here is the same output that we just had, 0, 1, 2, 3, 4, and 5. That's what should be coming out right here. So let's see if indeed that's what we get. 0, 1, 2, 3, 4, and 5. So what's different between these two things in here? Well, the for loop is a counting loop. All right? It needs to know exactly the number of iterations that you're giving it. Now, that when you do, and we'll look at lists and a few things as we go on in here, and there'll be times when the for loop is just really the best loop that you can use. But if you don't know how many times you're going to go through a loop, or if, let's say that we're going to ask the user a question, and we may go on and do some stuff, or we may be finished, you can't use a for loop for something like that. You literally would need to use a while loop. All right, the for loop is known basically as a pretest type of loop. All right, and we're going to look at other permutations of the for loop. This is pretty simple. Now, what if we did this? In here, we've got n equals 0 while n is less than or equal to 5. What if we made that equal to 6? What's going to happen in here? The answer is nothing. Nothing. Because n is 6, 6 is not less than or equal to 5. So we skip the entire body in here. If we change this to, let's say, 3, now we're not going to have 0, 1, 2, 3, 4, and 5, but instead we will have 3, 4, and 5. All right? Now, when we come in here and we do this, let's go back and reset this to 0. All right, because I want to talk about a few other things in here. All right, we've got this, well, n is less than or equal to 5, print n, okay? And then add 1 to it. Okay, fine. So let's say we could come in here and say something like this. If n is equal to 4, oops, forgot my colon there, break. All right, you may or may not have already been able to figure out what's going to print here. All right, it's 0, so it's going to say 0 less than or equal to 5. It'll print it, it'll add 1 to it, meaning it's 1. Is n equal to 4? No. So it'll come down and do it again. It'll print 0, then 1, then 2, then 3, then 4, and it won't hit 5 because n will be equal to 4, so we'll break. And just so you see this, let's make it 3. And let's run this again. All right. So you'll notice we get 0, 1, 2. All right. And it actually came in and did the 0, the 1, and the 2, and it added 1 to it right here. So it was 3. So we did break. So if we change this to 4, this will be 0, 1, whoops, to 4, and we run it again. This will be 0, 1, 2, 3. So what break does is it breaks you right out of the loop. It says get the heck out, for lack of better words. What if we did this? What if instead of break, we put in here the word continue? All right, so you saw the last one was 0, 1, 2, 3. But let's run this again. And we get 0, 1, 2, 3, 4, 5. Well, that's not exactly what I expected, so let's look. Oh, we've already printed it here. So let's move this up. We've already done all this. So let's do this right here. Okay, so if n is equal to 4, continue. So let's try that. Now what do we get? 0, 1, 2, 3. All right, we told it basically to skip. Let's make this a 2. We'd make it a little bit more obvious as far as what this is doing then. All right, try to run that. Well, it's doing the same thing. So let's save. Run this again. It seems as though this is almost stuck. There we go. All right. Let's see. The idea is this. Let me just say it like this. When you use a continue, the idea is it should skip everything else that's here and go back up again. I think the problem is I'm now not hitting the n plus equal 1. So let's do this. So this is print n. So let's come in here. Let's add 1 to it right away. All right, so it should be 1 and then 2. Well, let's see if it skips that. I think I'm in a loop here. I think that's the problem. Yeah, I think that I'm stuck in an infinite loop right here. So let's save. Let's exit this, and we'll just bring it up again. Well, I don't know what the heck happened there, but that's okay. We're going to fix it. Where are we? My Python course. There we are. Let's just do it like this. I'll start up again. Visual Studio Code. It should bring my file right back up. All right. So let's run it again. Hopefully it won't. There we go. We get 2 and 3. All right. And what is that? All right. As we go through here and start to run this, what are we getting here? We're getting 1, 3, 4, 5, and 6. That's what I thought we would get. All right, let's play computer here. All right, n is 0. While it's less than or equal to 5, so 0 is less than or equal to 5, we add 1 to n, meaning n is now 1. Is n equal to 2? Well, 1's not equal to 2, so we skip that and we print the value. So we print 1. Then we come down again. 1 is less than or equal to 5, so we add 1 to it. Now it's 2. N is equal to 2, so we hit continue. So we skip the print line, jump back up to the top. N is now 2. 2 is less than or equal to 5, so we add 1 to it, which gives us 3, etc. And we keep going. Another interesting thing you may or may not have noticed here is we get 6. Because we're adding 1 to it right here. So the last time we go through it, it's 5. 5 is less than or equal to 5. So we're adding 1 to it. If we didn't want the 6 to print, one way to fix that is we could remove that less than or equal and run it again. And now you'll notice we get 1, 3, 4, and 5. The takeaway from this should be that for and while are looping statements. And when you use a break inside of a for or a while, it breaks you out of the loop right there. If you use a continue inside of the loop, it does not break you out, but it skips everything after the word continue and it goes back up to the top. All right, hopefully that made at least some sense to people. And I want to mention that when I get done with this, what my plan is here, so we've now, go back up to the top, because we've now talked about for, while, break, and continue. We'll go to pass in just a moment. All right. But the idea is after I finish talking about what's left here in this keyword, is the next thing that I'm going to do according to my list is variables and data types. Now, the stuff that you see in here, it's going to kind of be taught together. What I mean by that is I'm going to write a series of programs next. All right. So I'll make another folder. And in that folder, I'll create a bunch of programs. The first one we'll create is we'll go back to that calculator that we created, but we'll change it around and we'll add some things to it. All right. That'll allow us to talk about the arithmetic operations, the comparison operations, the logical operations, and some control flow stuff as well. Then we'll go and we'll write a simple game. All right, probably a guessing game. And we'll do that, like I said, in our next series of videos. Okay, and we'll do that, and then we'll jump into some, as it says, core concepts, and we'll get into some stuff that's a little bit more complex. Lists, tuples, dictionaries, and sets. Talk a little bit about files. Talk some more about error handling. And the reason I'm bringing this up is if you notice here, error handling. All right, so why am I mentioning that? Because the try, the except, and the finally, and the assert, and the raise, all of those that you see there are going to involve exception handling. So we will talk about all those, but they will go onto my list here of things that will be discussed later. In fact, let's see with pass. I don't remember if that belongs on the list or not. So try and accept, continue, break, pass. Pass keyword does nothing. It's typically used as a placeholder for code that we haven't decided to write yet. All right. For lack of better words, all right, I was always taught that things like the word pass are like a stub. In other words, it's a placeholder. All right. So we've created a function called hello. And if we don't put any code in there whatsoever, it won't run. Because just to put def followed by the name and then parentheses and a colon won't run. But if we put pass in there, basically it just says pass over it. So it's something we will go over at a later time. All right. So again, looking in here. All right. That means that what we're up to next, let me move this up a little bit. All right, so after class, we did for, we did while, we did pass, we did break, and we did continue. But we will go over try, except, finally, assert, and raise at a later time. All right? Why? Because they're a little bit more, it's not even that they're more complex, but they're just going to involve some stuff we haven't talked about yet. And most of the stuff that's on near the end here also will be stuff that we'll talk about later. Now let's look at match and case, because those are interesting. The wordage is a little bit different than the wordage that's used in other languages. All right, so I'm going to literally grab their example here. But I'm going to modify it because it's kind of a silly example. So let me go back. This is what we've been working on. Again, I'll break this stuff up into multiple programs so that it'll be easier for everybody to take a look at it. I'll do that before the next lecture, and I'll give you a 5 or 10 minute primer on that where I'll show you everything that's been broken up into a bunch of separate things. Now, if I run this right now, nothing should come up. That's good. That's what I want. Nothing. All right. So let's go in here and let's look at the next one that they have, which is match and case. Now, this is kind of a silly example. So what I'm going to do is I'm going to change it to my own. So I'm going to say size equal, and I'm going to put in here medium. Okay. And then I'm going to do a match on size. And I'm going to say that if it is a small, we're going to print size small. Try that again. If it is a medium, we're going to print in here size medium. If it is a large, we are going to print in here size large. Now, hopefully, all right, you already can take a look in here and figure out what's going to happen. Because since we set size to medium, all right, it's going to come in here. It's not a small, so it's going to skip that. It's going to come in here and it's going to say, yep, it is a medium. So this should print size medium if I did it right. There you saw it, size medium. Now, one thing we have not been doing is I've been hard coding a lot of stuff in here. We're going to change that in the next series of lectures. When we go through, we're going to allow the user to put in some input. I didn't want to go into that right now. But what I want to mention here is match. In many languages, this is the word switch. All right? And you use a bunch of statements that are known as here as case statements. All right? And I don't remember. I'm going to look in here. Yeah, it doesn't have a default, but we'll figure that out in a little bit. So when you work with match and case, it's like an if. I could have come in here and said, if case equals small, print size small. Elif case equal medium. In fact, let's rewrite this. I'm going to keep what we have here, and underneath it, I'm going to rewrite it as an if. So don't worry, we're just going to put in here if size equal, well, we'll fix it up. Don't worry, it'll be fixed literally in a matter of seconds. All right, like that. So this is rewriting what I just showed you, but it's rewriting it so that rather than doing it as a match with cases, I'm doing it as an if with elifs. And you can see right here, it's not that match is saving us anything. We've got what? 1, 2, 3, 4, 5, 6, 7 lines. 1, 2, 3, 4, 5, 6 lines. Okay, but it's kind of a wash. All right. There are times when it makes a lot of sense to use a match case as opposed to an if with elifs, else's, etc. And sometimes it makes more sense to use an if. All right. Sometimes the choice is up to the programmer. Now, if I did this right, so we'll come in here. We'll change this to match size small, match size medium, and match size large. And we'll change this one to if size small, if size medium, and if size large. Now, if I did this right, it should print out match size medium and if size medium. Let's save it. And let's run it. And what you should see, match size medium and if size medium. So again, it's two sides of a coin or of the same coin, whatever you want to say. It's two ways of doing the same thing. All right. And students, in the past have asked, well, which one's better? And I come back and give the old adage, like which of your kids do you like best? And you might even say something, well, it depends on the situation. It's kind of what it is here. It depends on the situation. So we've talked about match and case now as well. Let's look at in and is. The async and the await, I believe, are going to go on to our list of things that we'll talk about later, but that's okay. So we're going to look at in and is. The in keyword is used to check if something is inside of something else. All right. What you have here is what's known as a list. In most programming languages, it's known as an array. And what we're saying in here is, okay, apple in fruits. It's saying to go look through fruits, and if apple is in it, it'll print true, and it'll look for pineapple, and since pineapple is not in it, it'll print false. All right, then we've got is, and is basically says in here, are these things the same? Do they refer to the same thing? Here they both refer to apple and orange, so it's true. Here they're different, so it's false. All right, we'll get much more on that later. The async and await I'm not going to talk about right now because they allow you to write asynchronous Python functions. We haven't talked about anything even remotely similar to that. So I'm going to come in here and I'm going to put into my list here async and await. Now we did just talk about in here in and is, but we really didn't do them due diligence. So I'm going to put in this list too, in and is. These are all things we're going to have to go back and talk about again later. All right, the last two things that are in here are global and non-local. All right, the global keyword, as it says, is used to define a variable that should refer to a global variable. What the heck does that mean? All right. Notice that we've said right here, x equal 5. All right. Then we've got this function here, define test. Okay. And inside of test, we set x equal to 100. All right. And then we call test. And then we print test out. And it says that it's going to print 5 out. All right. This test is, this x is local, so it's only known inside of here. I'm going to grab this example and I'm going to modify just a little bit. All right, hopefully just to try to make a point here. So again, let's come in here, and I know there's a much better way than the way I've been doing this for taking all this stuff and commenting it out, but I don't remember what it is, but we'll get it. We're almost finished here, but I think it's important enough to mention this to you. So I'm going to copy directly the example that they put in this article. I'm going to put it right here. All right, so x equal 5. Okay, and I'm even going to put in here print x. All right. And my guess is this is going to print 100, and then this is going to print 5. There's the 100 and there's the 5. So what the heck even happened here? Since we defined this outside of any function, it's a global variable. All right? But in here, we're redefining our own copy. So this is not the same variable. It's not a copy of it, technically. All right? It's only known inside of here. That's why when we call test and it printed it out, we may as well have named that something else, because it reverted back to its value that was set here. All right. Now, again, is that a great explanation? You might think, not really. All right. So let's take a look one more time and see what they had in that article. Again, it says it's used to define a variable that should refer to something that's global. All right. So it says test runs and it does not override the original. Now, what if we do want it to override the original? Then, as it says right here, we'd come into our example. Let's grab the whole example. Everything that's in here. Whoops. I'm going to grab the entire example here. All right. And I'm going to copy it down below. And I'm just going to change x to y. All right. So there it is. X equal, etc. Print x, etc. We're going to make this y. All right. And we're going to put the word global here. And I think I have to do it like this. There we go. Now, and we don't want that to be x, we want that to be y. Now, hopefully at least, this is going to print out 100, and so is this. Because here we're telling it to create a brand new local variable that's known only inside of test. Here we're telling it that we're using our global variable and to change it. So let's see what happens in here. So we'll do a save all and we'll run it again. And let's look. And you'll notice what we get is 100, which is the local one, 5, which is our global one, and then 100 twice, because we've used the global keyword to say that the variable that we're working with is not a copy that's local to the routine. It's the actual global variable itself. All right. And then finally, the last one that's here is non-local. It says the non-local variable keyword behaves like the global, but this works for variables inside of nested functions. And a nested function is a function within a function. I'm going to hold off on non-local, and I'm going to add it to my list here. So what has happened in here is there are 38 keywords. Out of those, you'll notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 out of 39, so more than a third I did not go over. And approximately 2/3, or maybe 60-some%, I did go over. All right, we will go over all of these. What I want to do before the next lecture is one thing, and that is I want to go back to here and I want to separate all this so that instead of being this ugly mess of over 100 lines, I'm going to create a whole bunch of different files. All right, one for each one of these. So I'll have one called calculator.py, another one called maybe matchcase.py, and another one called elif.py or something like that to try to help people and help them understand. So this has been part 2, shorter than part 1. It's about 35 minutes in length. So again, I went over this list of keywords, and no, I did not talk about every keyword. All right. at a minimum, what I'll do between now and the next lecture that I hope to do later today, all right, and have out later today. But what I hope to do is, as mentioned, to break this up into a bunch of different separate examples and then quickly go over that with you and then write a couple additional programs from scratch. All right. And I mean, just like I said, just thinking about it, we might take that calculator program and expand upon that. You know, maybe copy everything and have a calculator too. All right. And what we'll do to change this up in that calculator 2 program, for example, is rather than maybe we'll ask the user to enter 2 numbers, okay, instead of having them be generated. And then we'll go in and we'll write a simple guessing game. And I want to write this kind of in a tiered format. And what I mean is you'll be able to do this in one of 3 ways. All right, we'll have a simple mechanism where you will guess a number between 1 and 10. And you'll see how many guesses. I'll let you guess as many times as you want. We could put limits, but I'm not going to do that. That'll be a simple. Then we'll make a more, we'll call it medium. And that'll be a random number between 1 and 100. All right, so it'll be a little harder. Then we'll make it even harder than that, and it'll be a random number between 1 and 1,000. And we'll talk about that, and we'll let the user decide which one of these they want. And maybe we'll use an if with elif, maybe we'll use a match case in that, maybe we'll do it yet another way. So I'll be back with that. Everything I just mentioned to you, I'll be back with that shortly. Thanks for sticking around.